All right, we got cut off a little bit at the end there, but let's keep going. So we had found the variance. And remember what we did was we figured out the deviation. We squared it. We added them all up. We divided by how many there were, but then we realized that was kind of silly because you only divide by how many there are if there's a population. We don't have a population. We have a sample. So we're going to divide by how many there are, take away 1. And I didn't get too heavy into why that is, but just suffice it to say you want to make it a little bit bigger, but not too big. And the -1 makes it Goldilocks just right. Okay. Then we really are not interested in this at all because the variance doesn't have the same units as what you started with. See, variance is when everything was squared and added them up. But what good is that? I mean, it's not like you really want them to be squared, right? You want them to be the same units as what you started with. So what we can do is to undo the squaring that we had to do to turn everything positive, we can take the square root, and that's equal SQRT of those numbers. And then that would give you sigma alone, because, of course, square roots and squaring undo each other. And you could do the same for the sample number as well, right? Take the square root of this 198 point whatever equals SQRT of that, and you're going to get something called the sample standard deviation. Now, these two are really important to us in the first several chapters of the course. These two are actually, the variances are actually a little bit more important later on in the last chapters, and honestly, a Stats 2 course if you go onto it. Just because square roots are kind of a pain to work with mathematically, so sometimes it's just easier to leave them squared. They still measure variation. You can tell that the sample variance is larger, therefore the sample standard deviation is larger. And that will always be the case. You will always, always have a larger sample standard deviation than you would a population standard deviation, right? Because of sampling error, what we learned in chapter 1, the fact that a sample is never quite the same as the real population. So you always want to allow for a little bit more wiggle, right? And that's what these formulas do for you. Okay. So we have found sample standard deviation, sample variance. Oops, you know what? I'm going to color those green and yellow. Hold on. There we go. Now they're in there. And you can see we lived and abided by these formulas. We took the deviations, we squared them, we added them all up, we divided by n or n-1, depending on whether it was population or sample, and then we took the square roots to get the standard deviations. What a giant pain. So I know what you're thinking. You're thinking, man, there's a lot going on in there, and there is. So let's start with the first thing. What is the difference between sigma and s? Little o with a tail on it is sigma. Sigma is, oops, population standard deviation. S equals sample standard deviation, i.e. use this one if your data was a sample, and use this one if your data was a population, which of course is going to occur far less often, right? Notice that S will always be a little bit bigger than sigma. Hold on. Insert symbol. Sigma, there it is. For a given data set, because S is trying to accommodate for sampling error, i.e. that a sample is never the full population. So we have to allow for more wiggle room. All right. Next, we will not be calculating this by hand ever again. You're never going to have to do this. Let me show you how to do this. This is so simple. You're gonna kick yourself. All right. So population variance. Let me just do it right here. Okay. Population variance. Watch it. Equals var. Now I've got the newest Excel, so I can just use var.p. If you're with old Excel, you use var.p. Right, that one. So I'm going to do var.p, parentheses, that data, close parentheses, enter. Oops, I was using the wrong exam the whole time. My fault. This was the stats exam we were working from. Sorry. But still, there it is right there. 179. Look at it. var.p, that data. Done. Easy as pie.